Okay, this is U7C Logarithmic Functions Worksheet. So the first directions say rewrite. We're not solving, we're not using our calculator. It just says rewrite each equation in exponential form. So just review from yesterday. If you had log base b of x equals y, to put this in exponential form, you do a swoop. You always start with your base and then it's hanging low. So you write the base, but it becomes big. It was small, now it's big. It picks up its exponent, and you set it equal to x. So some people call this roll the log, because you're rolling something all the way over. Roll it over. So b to the y equals x. So this is exponential form. So in this case, we are going to start with the base. I always circle that. So that's what you start with. You write 6, and it becomes big. It was small, so it becomes big. It picks up the exponent, and that becomes small. So this becomes big, and that number becomes small. And then you set it equal to 36. And that is a true statement. So that's right. Circle the 289. That's your base. Pick up the exponent, 1/2, and set it equal to 17. So the only one that's small in this case is the exponent. That 1/2 becomes small. Everything else is a big number. And that is true because that 1/2 is really square root of 289, which is 17. So this one, your base is 14. So write that. Pick up your exponent, -2. Whenever you have a negative exponent, you're going to have a fraction that it's equal to. So that's why that is a fraction, 196. And your base in this one is 3. Pick up the 4. Set it equal to 81. That's all you have to do. Put it in exponential form. Now the other one is rewrite in log form. So in log form, you have to remember that you have 3 boxes to fill in. This one right here is the base. This one is going to be your exponent. And this is your final answer. So you have 3 boxes. So start by doing that. So you have log. And you have 3 boxes. So the base is 64. That was big. It's going to become small here. And I give myself a big enough box. So this is 64. That's saying, oops, you can't see that. 64 goes in this box. Okay, the exponent for 64 is 1/2. That goes over here, 1/2. And the final answer that it's equal to is equal to 8. That goes right next to the log. So make sure the 64 is hanging low. The base hangs low. It goes from a big base to a small base in logarithms. So again, the base is 12. That goes here. I always put my equals over here. The exponent is always what a logarithm is equal to. A logarithm is equal to an exponent. And the 144, I call this the final answer. Some people call it the value. It goes right next to log, and it should be the same size as log, same line as log. So if you had lined paper, the only thing that's hanging lower is that base. So sometimes I like to do the lined paper. So we have log. Base is 9. That goes down here. Then it equals the exponent, and what it was equal to, 1/81, goes right next to log. So this one, lined paper, you have log. The base is 1/12. It is equal to the exponent. This is what it was equal to. That goes right next to log. So right now, so far all we've done is practice just rewriting in different forms. And now we're going to rewrite this in exponential form again. So in exponential form, you start with your base. You swoop, pick up the v, and it equals 15/16. That's a really weird problem. I don't like it. Put this one in exponential form. Start with your base, v, swoop and pick up 4. Set it equal to u. Start with your base, 7/4. Pick up its exponent, set it equal to x. I'd probably put parentheses around that. It's a fraction. Our base is 2. Pick up u, set it equal to v. Start with u, pick up the exponent, set it equal to v. 14, start with the base, pick up the exponent, set it equal to x. So those were some weird problems. I didn't like any of those. Rewrite in log form. So start with log. The base, line paper. The base is U, that hangs low. The exponent is what it's equal to, that's down here. And put a V right next to it. That's your final answer. Line paper, log. Base 8, equal to the exponent. What it's equal to goes right next to log. Log. Base is 1/5. Equals the exponent. What its the whole thing's equal to goes right next to log. Line paper. Log. Base 6. What's it equal to? Y. That's the exponent. Exponent's always what logarithm's equal to. The answer here, x, goes right next to log. Log. Base. 9. Equal to the exponent. X goes right next to log. Log. Base. Equal to exponent. The answer, 123, goes right next to log. All right, now, the rest of these you can actually do on your calculator, but it'd be nice if you guys could do these by hand. So I'm going to do a couple of these by hand, and then you guys, will show you how to do them on the calculator. So this one, you're supposed to set equal to x. And if you write this as an exponential equation, you start with the base, and you swoop. 4 to the x equals 64. Well, you can write 64 as 4 cubed. So the 4's cancel, and your answer is x equals 3. So on the calculator, log 464. For the newer calculators, you can press alpha, this alpha button right here, the green one. Press alpha, and then window. And you get a drop down. So we want number 5, log base. So you press 5, and you put a 4 in here, and you put in a 64 here. And you press equals, and that's your answer, 3. For the older calculators, to do this problem right here, log 464, you have to change it to base 10. It's called change the base format. You would put in log 64 divided by log 4. So you'd press in log, here's the log key right here. It's right under x squared. Press log 64 divided by log, what did I say, 4? Log 4. And you press, so that's what it looks like, and you press enter, and it's 3. So you can do those, you can do all these on the calculator, but for now, I'm just going to do them all by hand. So it's 4 to the x equals 16. You can change 16 to 4 squared, so x is 2. You can do that on the calculator also. Set this equal to x, you get 5 to the x equals 125. 125 can be written as 5 to the third, so x equals 3, because the 5's cancel. 343 to the x equals 7. Now 343 can be written as 7 cubed, but there's an x there, and then 7 is just 7 to the first. So we ignore the 7's, but you set 3x equal to 1, and x is 1/3. Check me on the calculator at any time. This one, 64 raised to the x equals 4. So 64 is 4 to the third x equals 4 to the first. So you set 3x equal to 1, and x is 1/3. Can someone come up here and pass out the homework? I'm making a video for your homeworks right now. Thanks, William. I'll give everyone one of those. We're just doing homework today. 6 to the x equals 216. 216 happens to be 6 to the third. Cancel your 6's, and x is 3. This one, if you set it equal to x, you get 3 to the x equals 1 over 243. 243 is 3 to the 5th. So this is going to be 1 over 3 to the 5th. And what you do here is if you have something in the denominator, you bring it to the top as a negative. So x is -5. So 2 to the x equals 4. 2 to the x equals 2 squared, and x is 2. 2 to the x equals 16. 16 is 2 to the 4th. So x is 4. Because you ignore the 2's. 6 to the x equals 1 over 2 16. So 6 to the x is 1 over 6 to the 3rd. If you have this in the bottom, it comes to the top as in negative 3. Ignore your 6's, x equals negative 3. Now to simplify these, I gave you some properties yesterday. So if you have a base 12 here, and then you erase it to a log base 12, the 12s are inverse operations, so they cancel, and your answer is just this 144 right here. So in this one, there's the base x, they cancel, your answer is 72. 5's cancel, answer is 17. Now this one, these are not going to cancel because they're not the same thing. So you have to change 9 to 3 squared. Then this 2, oh, I haven't even showed you this yet. So the 2, actually, there's a little trick here. This 2 goes out front, like a 20 squared right here. Then the 3's cancel, and your answer is 20 squared, which is 400. But we're going to check that. So we have 9 raised to the log of base 3. And then she terminated 20. So I just type that in, and it's 400.